You've made it to the end of Chapter 1. This is Chapter 1, Lesson 6. We'll just practice some example problems here that might be related to the real world involving those exponents and applying the things that you've learned throughout the chapter. So, some real world problems. Find the 2 square roots of 81. This might be the first time you're hearing that there could be 2 square roots of a number. That's definitely true because we know that when we multiply a positive times a positive, we get a positive, and when we multiply a negative times a negative, we get a positive. So when we're finding the square root of a number, it could be either it's positive or it's negative. Just like in this example here of the square root of 81, the square root can be 9 or negative 9 because 9 times 9 equals 81, or negative 9 times negative 9 equals 81. So let's apply that. What would the 2 square roots of 144 be? Most of you know that the square root of 144 is 12. 12 is the positive square root of 144 since 12 times 12 equals 144. But now you know that we can also have a negative as a square root. So it's going to be the original one's opposite. Negative 12 is the negative square root of 144 since negative 12 times negative 12 is 144. You're going to be asked to find the cube root of numbers. The cube root, remember, is a number that's multiplied by itself 3 times to get that number. So the same rule will not apply. We can't have both a positive and negative cube root. Some of you might know some of these exact cube roots by heart. For example, 216, the cube root is 6, since 6 times 6 times 6 is 216. Just a reminder that if you don't know the cube root by heart, we can use a factor tree. So I'll demonstrate that here. I'm going to start factoring out numbers I know 216 can be divided by, and I'm going to keep it simple. Since 216 is even, I know that 2 can go into it. 2 is a prime factor. And 216 divided by 2 would be 108. I keep going. Again, 108 is an even number, so I know I'm going to be able to divide by 2. 108 divided by 2 is 54. I'm going to keep going along that lines and keep using 2's just because I think it's simple. 54 divided by 2 is 27. Now I come to a place where I don't have an even number, but 27 is one of those numbers that a lot of you know the factors by heart. 3 times 9. 3 is prime. 9 is not, so I'm going to break that down into its 2 prime factors of 3. And since I'm dealing with a cube number, I want to split it up into 3 different multiplication problems. So those factors of 2, 2, 2, and 3, 3, and 3 each need to be evenly split between these 3 parentheses. So I'm going to put 1, 2 in each, and 1, 3 in each. All that. So now that tells me whatever that multiplies to be in one of those parentheses, which in this case is 6, is my prime is my cube root of 3. What if you have an example like you do in number 6? Find the cube root of 127. Well, you would need to find the cube root of both the numerator and the denominator. But we know the cube root of 1 is going to be 1. So that's easy. So let's just find the cube root of 27. I'll write that 1 up there to start. Again, I'm going to break this down into prime factors if I don't know this by heart. I know that 27 is the same as 3 times 9. 3 is a prime number. I like to circle it so I know I'm done on that side. And 9 also breaks down into 3's. So 27 is equal to 3 times 3 times 3. So that means the cube root of 27 equals 3. So my denominator is 3. So 1/3 is the cube root of 1/27, since 1/3 times 1/3 times 1/3 equals 1/27. Here I'm going to show you some other ways and some other problems where you're going to need to use exponents. They show you some examples here where they give you a variable squared or a variable cubed equals a number, and they want you to solve for variable. So the opposite of squaring a number is finding the square root. So when they say x squared equals 22.09, how to solve that, they found the square root of 22.09. Now, this would be a problem you'd be allowed to use a calculator on, because I don't expect anyone to know what multiple is 22.09. Just remember, when finding the square root, though, that we can have both a positive square root and a negative square root. Same thing with a cube root here, 2,744. That's a larger number. I'd probably allow you to use a calculator there. But again, with dealing with cube roots, we will not have a positive and a negative. You will only have a positive. So let's practice with 225. X squared equals 225. So to find that, what I'm going to do, I would plug into a calculator the square root of 225, and I would find out that the square root is 15 or negative 15. So 225 equals 15 times 15 and negative 15 times 15. So both the positives, I'll abbreviate, and negative square roots work here. So x equals 15 or negative 15. The cube root, so I know that 64 has a square root of 8. So I'm going to use my factor tree to help me out there and break that down into 8 and 8. And I'll break each of my 8s down into prime factors if I can. The 2s are prime factors, but the 4s are not. So I keep going. So now I see that I have 1, 2, 3, 4, 5, 6 2s. So if I wanted to break that up into 3 multiplication problems, I'd have 2 2s in each, which is the same as saying 4 times 4 times 4. So x cubed equals, if x cubed equals 64, I'm going to do x equals the cube root of 64, which is 4. Again, so I solve for x by taking the cube root of both sides. That's the symbol. And last, let's try one of these that would be classified as a real world problem. So Maxie purchased a table for her apartment. The table is a square with an area of 870.25 square inches. Remember, drawing a picture can always help. Okay, what's the side length of her table? A big clue there is that the table is a square. Anytime you hear that, you are going to simply know that you need to find the square root of 870.25. Plug that into a calculator, and you would see that the answer is 29.5. In this example, it wouldn't make any sense to give also the negative. The length of a table could never be negative. Keep that in mind. Let's do number 17. So Peter has a square piece of cardboard. Okay, I'm going to draw that piece of cardboard with an area of 0.36 square meters. Just a little label there. What is the side length? Again, they give us a huge clue in the question there when they say he has a square piece of cardboard. So let the side length of the cardboard be the square root of 0.36. So x squared equals 0.36. I'm going to turn that to solve by finding the square root of both sides. So solve for x by taking the positive square root. Again, we're talking about length here, so it couldn't be negative of both sides. So x equals 0.6 meters. I'm using a label because we are talking about a measurement here. So the side length of the cardboard is 0.6 meters. Okay, great job finishing chapter 1. Remember that all of the videos for chapter 1 are going to stay on the website. So anything that you feel you need review, please go back and look at.